IR persistent artifacts. Malware favorite path. Among malicious codes, there is a kind that is executed immediately to affect the system, and there is a kind that monitors the system while hiding for a long time, then infiltrates to another system. In the former case, it deletes traces using a method such as self-deletion after execution, but in the latter case, it hides in the system as much as possible until the goal is achieved. Malware targeted to a specific organization is difficult to detect using an organization's security system because it uses pre-scanned information or it attracts malware optimized by the downloader. However, even if the vulnerability infiltrates the internal network, it is necessary to attack again in order to achieve additional purposes such as personal information capture, confidential information capture, malicious code distribution, etc. Such secondary attacks may take at least 1 to 2 weeks to several months, depending on the organization's internal security policies and organizational networking. As a result, there is a high probability that malicious code that is optimized will be detected over time. Although there are many ways to hide malicious code, such as rootkit techniques to slack area usage, attribute changes, and file name changes, the most common way to conceal malicious code from an attacker's point of view is to use a folder that is not frequently used by users. Folders that are not used by the user are not subject to real-time detection of AV, so there is less risk of detection unless a close inspection is performed. Of course, optimized malware is hard to detect even if you perform a close inspection. The system folder is where the main system files of the Windows are located, and to conceal, system file and the file name is changed or the path is changed, then saved. SYSWOW64 is a folder that exists only on a 64-bit system and exists for compatibility with 32-bit. If the 64-bit system files are located in the %systemroot %system32 folder, %systemroot %/SYSWOW64 contains the 32-bit system files. Therefore, in a 64-bit system, it is necessary to examine both folders. Since Windows Vista, the user's home folder is under %systemdrive %users /. Looking at the subfolder, there are basic folders, public and default, in addition to the user's home folder. In the public folder, files, common pictures, videos, etc., common to each user are stored. In the default folder, files for initial configuration are stored when a new user is created. Because these folders are not usually accessed directly, an attacker often uses them as a place to hide. Also, if malicious code is placed in default, it is automatically copied every time a new user is created. The application data folder appears only when you change the folder properties because the data folder in which each user's application data is stored is hidden. Data folders are also not commonly used, so the path is often used to hide malicious code. The Windows Recycle Bin folder is protected by the operating system, so it only appears when you change the folder properties. Under the Recycle Bin folder, each user's SID folder appears, but each user deletes the file in the SID folder. The contents of the Recycle Bin on the desktop are the contents of the SID folder of the logged-in user. Malicious code frequently hides at the same level as the Recycle Bin sub-SID folder. The System Volume Information folder, where system restore points or volume shadow copies are stored, is protected by the operating system. If you change the folder attribute, you can check the existence of the folder, but you cannot check the contents of the folder. To check the contents of a folder, you need to change the access permissions of the folder. Thus, malicious code can be safely concealed for a long period of time because some security solutions cannot diagnose the subdirectory of the folder for this reason. The temporary folder is a temporary path used by malicious code to be automatically injected into the system or dropped by the dropper, rather than an attacker's intent. A copy of the malicious code is often present. The web browser cache folder is likely to contain malicious code using a web browser. It also stores malicious code in places such as the ActiveX download folder and the Start menu folder. An attacker can change the location of malicious code at any time. Therefore, the above-mentioned root needs to be used as a reference index rather than an absolute index. When an infection system is analyzed in an organization, if the malicious code uses a specific folder for concealment, it can be used as an infringing indicator to find an additional infection system. Malware file name. In the case of malicious code that enters the system via the network, the name of the file may be manipulated for the purpose of circumventing the policy of the security solution. In some cases, after the malicious code is executed on the system, the process is created with a name similar to the name of the normal process so that the malicious code cannot be detected. This way, malicious file names are often manipulated to conceal in the system or to hide the process name. Therefore, it is difficult to judge whether the file name is malicious or not, and it is important to check whether the internal data of the file has a malicious pattern. The following is the name pattern of malicious files. You can check various patterns such as random name, extension change, alternate data stream, and so on. Malicious code hides the process by creating a process name that is similar to the name of a system process running on a Windows system. This shows an example of creating a malicious process with a name similar to the name of svchost.exe, a process for jurisdiction of services in Windows operating system. Hidden data. Data hiding is a technique that hides data so that it cannot be easily detected. It is used as a technique to prevent an external person from detecting malicious data stored in case of an intrusion. The basic method is to change the file attributes of the Windows system to hidden. However, since this method cannot hide the contents of a file, it is used for the purpose of hiding the existence of the file to the user rather than the purpose of hiding the contents of the data. It can be checked by searching the file with the hidden attribute. You need to use encryption to conceal the stored data, but you can hide the contents of the file using the file encryption provided by the New Technology File System, NTFS. This method encrypts a file using the functions provided by the file system. Therefore, you can easily find the encrypted file by searching the settings of the file system. File name extension is a part of the name of a computer file that is used to indicate the type of file and its role. For example, file name extension allows a.exe to be an executable file and a.txt to be a text file. However, file name extension does not determine the file type. For example, if you change the executable file a.exe to a.txt, the file named A is still an executable file. In this way, there is a way to hide the file or to induce the user to click by setting the file name extension differently from the file type. Whether a file was hidden by changing the file name extension can be checked by seeing if the signature information, according to the file type, matches the file name extension. Slack space is a waste space caused by difference between the physical structure and the logical structure of the storage medium. In other words, it is physically allocated space but cannot be logically used. Slack space is usually divided into RAM slack, drive slack, file system slack, and volume slack. The term file slack is the term used to describe a combination of RAM slack and drive slack. The reason is that both RAM slack and drive slack are slack based on files. In such a slack space, there is a possibility that data of a previous file that has been deleted exists. There is also the possibility that data with a specific purpose is intentionally hidden. Therefore, it is necessary to check the existence of the above-mentioned hidden file by examining the data of the slack space when analyzing the accident. The first sector of the disk has a structure named MBR, Master Boot Record. A reserved space is allocated from the MBR to the beginning of the first volume. This area is called MBR slack. In previous versions before Windows XP, a total of 63 sectors were allocated as reserved space, but after Windows Vista, 2,048 sectors were allocated. In the case of a Windows file system, a reserved area may be set to utilize a data structure that will be needed later. Since this reserved area is an unused area, it is possible to intentionally conceal the data. FAT, File Allocate Table 12, 16, 32 file system is assigned reserved area and FS Info area. These areas are also unused areas which can be used to hide data. The EXFAT is also assigned an extended bootcode area and a reserved area of VBR. You should also look into the area where VBR backups are stored, and NTFS should investigate the wasted area of VBR, the area of MFT records 12 to 15, and the backup VBR area. The HPA is a feature added from the Advanced Technology Attachment, ATA-4 standard, and the DCO is an added feature from ATA-6. These areas are reserved in advance by the HDD and cannot be accessed via the BIOS. It is an invisible area in the OS. Because the HPA and DCO areas are not identified by the BIOS, suspects can use them to intentionally conceal evidence. Let's take a look at MFT and INDX slack. INDX slack can be very useful for targeted attack analysis. The following figure shows an abstracted NTFS file system. The volume boot record area comes up in front of the volume in cluster size, followed by the master file table area, where all file information on NTFS is stored. When a file is stored on NTFS, the file data is recorded in the data area, and the meta information, such as file name, time information, size, and the like, is stored in the MFT record structure of 1024 byte size. The MFT record of all files on NTFS is the master file table, MFT. This figure is a more detailed representation of the MFT, and it shows a collection of MFT records. The first 15 MFT records in the MFT file are reserved for file system management. If you format the volume, the MFT record is basically composed of the MFT record. The following MFT record consists of the operating system installation file and the user file. This figure represents an MFT record of 1024 bytes. Header structure comes first, followed by fixup array to detect MFT record change. Then, several attributes come in. The meta information of the actual file is represented by this attribute. The attributes defined in NTFS are as follows. Most are attributes used for file system metadata files for file system management, and regular files and folders use only some attributes. If the file is a regular file, it has 3 attributes as follows. The $standard underscore information attribute stores 4 time information. Creation, modification, access, and MFT record change time. The $file underscore name attribute contains the parent MFT record location information, create, modify, access, MFT record change time, file type. $data attribute stores the actual file data. If the size of the file data is smaller than 600 bytes, the data can be stored in an empty space in the MFT record. Therefore, NTFS stores the data in the MFT record without allocating a separate cluster to the data area. This data is called resident data. When data is added to the data stored in the resident data format and can no longer be stored in the 1024-byte MFT record, a separate cluster is allocated to the data area. When a separate cluster is allocated to the data area, only the position value of the cluster is stored in the $data attribute. In this process, the $data area of the MFT record grows and shrinks, which causes slack. This slack allows you to see the data in the file. Of course, you can check the cluster to identify the data, but if the file is deleted, the cluster can be overwritten, so you can see part of the file data with only MFT record. Folders do not contain data, so the $index attribute is used to represent the folder's subitem instead of the $data attribute. Folder subitems are represented as index, which is represented by the $file_name attribute of each file and folder. When a file is added to a folder, the index structure is increased. Since there is room in the MFT record, the index of the item in the folder is stored in the MFT record until the MFT record is full. When a file or folder within a folder is continuously added and cannot be stored in the MFT record, a separate cluster such as $data is allocated and stored. In this process, the index structure is increased and decreased like $data. By checking the slack in the MFT record, you can identify deleted files and folders created under a specific folder. In the case of a targeted attack, identifying the index slack can be a great help in identifying a targeted attack because it prepares for lateral movement under a specific folder. In the index structure allocated to the separate cluster, the index structure is successfully recorded in the order of the folder files. In the case of the index structure allocated to a separate cluster, because the number of files under the folder is large and even if last recorded file is deleted, the index structure of the corresponding file is not reset. By checking this index slack, you can identify the traces of files that existed under a specific folder. Utilizing the slack of MFT record and index clusters to identify deleted files is helpful in tracking targeted attacks. Related tools are as follows. ADS is an abbreviation of Alternate Data Stream. In the NTFS architecture, multiple data streams are supported. This means that a file can contain more than one data. By using this, desired data can be concealed in a specific file. For this reason, it is necessary to analyze the files for which ADS is configured when analyzing the incident. ADS is a basic feature supported by Windows NTFS, so it is not difficult to detect. It is also not difficult to detect data hidden with ADS. The following is the screen where ADS is configured by dir command, which is installed by default in Windows. As mentioned earlier, it is not a difficult task to retrieve the files that ADS has set up. Check the dir options on the screen. The following is an example of a command to configure ADS. One way to delete ADS is to copy the file to a volume made up of a different type of file system than NTFS, or to delete the main stream. In addition, we introduce a tool called Alternate Stream View that can be downloaded free of charge from the Internet. It is an ADS detection tool and can be downloaded from the URL. Time manipulation. All files stored on the Windows system contain time information. The time information of a file means the time associated with creating, modifying, accessing, and modifying the file. The time we speak here refers to the time of last modification, access, or modification. time information of Windows file is stored and managed in File System. Again, the time information of a file can vary slightly depending on what kind of file system you use. As mentioned earlier, the time information of a file consists of creation, modification, access, and modification time. If the files are copied, deleted, or compressed, how the time to create, modify, access, and time to change has been altered should be considered. In the case of NTFS, a file system for Windows systems, a total of 8 pieces of time information are composed in one file. Attributes of creation, modification, access, and change will be set up in the $standard_information and $file_name. It is possible to analyze the behavior of the user by analyzing the time at which the time information set in each attribute is updated. Please refer to the table in the data for the update of the behavior time information. When malicious code enters the system and runs, it synchronizes its time information with time information such as system files ntdll.dll and rundll32.exe to hide itself. The Windows APIs that modify the time information are setFileTime and NT_SetInformationFile. SetFileTime can be used to create, modify, or change only the time of the file, and NT_SetInformationFile can change the creation, modification, access, and change time of the MFT record. If you modify the time information with setFileTime, it is easily detected as the MFT record change time. However, since NT_SetInformationFile can change the creation, modification, access, and change times of MFT records, it is not possible to confirm the MFT record change time alone. However, if you use NT_SetInformationFile to change the time of $standard_information changes, and the time of $file_name does not change. If you change the time with NT_SetInformationFile, you can compare the time recorded in $file_name to detect it. To detect time-modulated files, first sort the MFT record modification times to identify the files that are synchronized with the main system files. This is to check the malicious code trace based on the time information of the main system file. There are a variety of ways to examine files that are likely to have changed time information. A typical example is an investigation of a file whose creation time in $standard_information is earlier than the creation time of $file_name. This is because a malicious user is changing the time value of a specific file beforehand. Next, identify files with high time precision. For example, the nanosecond time precision would not be 0, such as 11 to 23 to 13.00000000000. This is a phenomenon that occurs when the time is arbitrarily changed. In addition, there are various analysis methods that can detect the change of time information, such as a method of detecting and analyzing a file having the same time information, and an analysis of an increased pattern of an MFT sequence number of a main folder. File system tunneling refers to the ability to keep the creation time unchanged if a file is created with the same name in a folder in a short period of time. The tunneling function is basically supported by both FAT and NTFS. If you delete or rename a file, the existing short/long file name and creation time are stored in the cache. If you create a file with the same name or rename a file in the same location, first search the cache for information of the same name, and if there is the same information, restore the cache information as it is. As a result, the creation time is reflected in the cached time rather than the current time. Be aware that not considering file system tunneling can result in inaccurate analysis. file system tunneling settings can be checked and changed in the registry. The following is a list of tools that can change the time information. It can be downloaded free of charge through the URL. Autoruns. Autoruns is an application that runs automatically when an operating system or a specific application is executed. It is a function that can provide convenience of automatically executing without users' arbitrary operation, but it can also allow malicious code to be continuously executed. For this reason, it has to be analyzed in the case of an accident. There are two types of autoruns: file system autorun and registry autorun. All autorun lists are available with a tool called Autoruns provided by Microsoft. Here is a list of free tools to check the Autoruns list. It can be downloaded free of charge through the URL. This is a list of Autoruns items that can be checked through the Autoruns tool mentioned above. They provide necessary information such as Log On, Explorer, Services, Boot Execute, and so on for incident analysis. Task Scheduler. Task Scheduler is a service provided by the Windows system, which is a service that runs application programs when certain conditions are met. For example, you can run a.exe every day at 1 p.m., run the application using conditions such as log file backup at system shutdown, log on of a specific user, and execution of a specific file. These task schedulers have two important elements: trigger and action. Trigger is a condition in which a task is executed, and an action is what is performed when a task is executed. In the previous example, a schedule of every day at 1 o'clock is trigger and execution of a.exe is action. The following is a list of trigger condition provided by Windows. Additional settings allow you to apply settings such as work delay, repetition interval, job stopping, activation, expiration, and usage over the next period. The following is an action item that can be set in the Windows Task Scheduler. You can set program start, send mail, message display function. When the task schedule is created, it is stored in the Tasks folder under System Root and in the Tasks folder under System Root and System32. Tasks created with the AT command are stored in the System Root and Tasks folders, and tasks created with SCH tasks and tasks.chd.msc are stored in the System Root, System32, and Tasks folders. The following is a summary of job scheduler creation and management tools and job file analysis tools. Task scheduler creation and management is made possible by using AT, SCH tasks, and tasks.chd.msc, which are provided by Windows. You can also use a tool named Job Parser as the job file analysis tool. The tool can be downloaded for free from the URL.